Hi, my name is Darren Chwabuni from F2T1. In this video, I'm going to talk about Chapter 7 and Chapter 9. Okay, let's take a look at question Chapter 7. Determine the values of R and alpha, where R is bigger than 0 and alpha is smaller than 90 degrees but bigger than 0 degrees, so that 3 sin theta minus 4 cos theta is equal to R sin theta minus alpha. So we use the formula of compound angle. We found that 3 sin theta minus 4 cos theta is equal to R sin theta cos alpha minus R cos theta sin alpha. We compare the coefficient of sin theta and cos theta. We found that R cos alpha is equal to 3 and R sin alpha is equal to 4. We square both equations. We found that R squared cos square alpha plus R squared sin square alpha is equal to 3 squared plus 4 squared. So we factorize it and we can find that cos square alpha plus sin square alpha is equal to 1, so that R is equal to 5 or negative 5. Since R is bigger than 0, so R is equal to 5. And then we have to find the angle of alpha. R sin alpha over R cos alpha is equal to 4 over 3. So alpha is equal to 53.13 degree. Hence, solve the equation of 3 sin theta minus 4 cos theta is equal to 2. Just now we found that 3 sin theta minus 4 cos theta is equal to 5 sin theta minus 53.13 degree. So the basic angle we get is 23.58 degree. And then we know that positive sign is at quadrant 1 and 2. After that, we have to find the range. The range given is between 0 to 360 degree. So we have to change the range because the equation given that theta minus 53.13 degree. So we minus 53.13 degree. After that, we have two answers. One is 23.58 degree and another one is 180 degree minus 23.58 degree. So both answer with plus 53.13 degree. So the final answer is 76.71 degree and 209.55 degree. Now let's look at question chapter 9. Find the derivative of fx is equal to 1 over x plus 1 by using the first principle. So we use the formula f prime x is equal to limit h towards 0 f x plus h minus fx over h, and then we substitute it and make the same denominator. So we will get that f prime x is equal to limit h towards 0 x plus 1 minus x minus h minus 1 over h times x plus h plus 1 times x plus 1, and then we cancel out h, so we will get that minus 1 over x plus h plus 1 times x plus 1, and then we substitute h is 0, so we will get that f prime x is equal to negative 1 over x plus 1 squared. Now look at question B. Find dy dx of y is equal to e power of 2x at 10x. So we use the product rules. U is equal to e power of 2x and v is equal to 10x. So du dx is equal to 2e power of 2x and dv dx is equal to 6 square x. So we use the formula dy dx is equal to u dv dx plus v du dx. We substitute it and we'll get that e power of 2x 6 square x plus 2 e power of 2x 10x, and then we factor out e power of 2x, so we will get that e power of 2x times 2 10x plus 6 square x. Since 6 square x can be replaced by 1 plus 10 square x, so we rewrite the equation, and then we found that 2 10x plus 1 plus 10 square x in the form of quadratic, so we use the calculator to simplify it. So for final dy dx, we get that e power of 2x times 10x plus 1 squared. Next, we look at question C. Use implicit differentiation to find dy dx if y ln x is equal to e power of x minus y. So we differentiate both sides. For left hand side, we use product rules. So u is equal to y and v is equal to ln x. So du dx is equal to dy dx and dv dx is equal to 1 over x. So for left hand side, we write it in the form of u dv dx plus v du dx. And then for right hand side, we differentiate e power of x minus y, so we get 1 minus dy dx times e power of x minus y, and then we expand it and move dy dx times e power of x minus y to left hand side and y over x to right hand side, and then we factorize dy dx out. So for final answer, dy dx is equal to e power of x minus y minus y over x over ln x plus e power of x minus y. Well, that's all from me. Thank you.